Jana, welcome to Stories in AI. How are you today?
I am great, Ganesh, and I'm so excited to be here because I love your energy.
Oh, I love that. And I really, really sincerely thank you for taking the time. And I know it's been coming out of the Thanksgiving week. I'm sure you have a million things going on. So really appreciate you prioritizing this. Why don't we just get started and, get into, would love to start with your story. Tell us your personal story and your journey so far.
Um, wow, that's such a big question. So I was sent to school to become an accountant. My whole family's accountants, and I became the black sheep when I became a mathematician instead. And I just liked math. It was always fun for me. And I was fortunate to be at actually a small school. I went to school in Arkansas, and we didn't have research. And so to do research, I had to go outside, which was awesome. As it turns out, I found out about the National Science Foundation and their REUs, the Research Experience for Undergraduates. And that ended up getting me out to Los Alamos, and I worked at the national lab there. And I got to learn, this is a long time ago, um, uh, more than 30 years at this point. I got to learn about neural nets. And that's really what started me on this journey of not just AI, but really just advanced technology. And at some points it was called AI, and then it wasn't AI anymore. It's that thing that once we understand it, it's not AI anymore. And so I've done, natural language processing. I was at one of the early search engines. I did expert systems for the trucking industry and all kinds of pricing optimization, lane optimization, all that fun stuff. And I've just had an amazing time just using math and computer science and applying it to business for the last 30 years.
No, it's
Or
it's fascinating your journey, and um, especially like 30 years in AI is like, I don't know, like it's like revolutions over revolution that you've gone through, right? I'm sure, right? It's like all the three different winters that we had gone through, all the different evolution. But it's interesting, you started off with your interest in neural nets, right? And I'm pretty sure neural networks had a much different meaning back then when you started than what it's actually known for today, right?
I mean, sort of. They're more similar. I mean, and that is not to take away any of the advancements
Sure.
that have happened. It's giants standing on the shoulders of giants, and but it's really the same basic concept that we were looking at and trying to use 30 years ago as what has been advanced again now. Um, because of two things. Back then, I didn't as much because I worked at the national lab and we had lots of equipment to get data from. And then we had a lot of compute power. So at the time, what's really different is that we didn't have the compute power that we have now. So I had to go and learn, how to work on the craze. I learned using connection machines, so thinking machines, connection machines, and that's what we had to use.
Yep.
And not many people had access to those. So there wasn't as much research going on. It wasn't really until the internet opened up the data side and compute, has gotten so cheap and so accessible that everyone was able to then start using these, basic tools, the neural nets, and advancing them and improving them. So they're less different, remarkably, over 30 years, and it's more just that things that to support them are now available to everyone, so more people can use them and make those great improvements.
So, Jana, fascinating history and great background in terms of how you started thinking about these things from the back. But it's interesting how the evolution of AI has been from symbolic logic to expert systems to now swinging the pendulum all the way out to data driven machine learning and deep learning with the advent of deep neural networks. I do believe that they're like fundamentally different approaches on either sides, but have we swung the pendulum a little too much on one side? Because like you were also talking about back in the day when you were um, um, working on the challenges on take that back, right? But you were telling me about your background where when you were working on AI, you were working on the entire full stack of AI, right? From infrastructure, the dependencies and stuff. Well, that also gave rise to a lot of system level thinking, which was needed to solve real hard problems. Well, today, people have no idea what infrastructure it runs on. I just use libraries, I run code, and I'm completely abstracted away. And you're just using, data driven machine learning. Have we swung the pendulum a little too much on that side? Are we not being able to? Is that why we're not solving the hardest problems? What's your thoughts on that?
I don't think it's why we're not solving the hardest problems. That's interesting. I hadn't really thought of that before. Um, Let me add, it's such a great question. I do think that many people that are using machine learning right now, particularly the libraries, um, it would benefit by going back and understanding some of the symbolics approach and what was happening then, because we are definitely being very data led, and what we're not understanding is that most of that data is driven by humans, and humans have a logic that doesn't come out in that data exhaust or the data dust that's left. And so to understand that, we need to put more context around. We also generally need to teach the machine more higher level concepts of things. So, one of my favorite examples, people love to always say to me, well, if AI is so smart, why do I get these stupid recommendations for movies or things to buy or things like that? And one of my favorites was when someone sent me March of the Penguins being recommended as a violent movie. And how can cute, cuddly penguins be violent? And I said, well, you have to flip that around a little bit, because the machine doesn't know. The machine's just fed all of this data. And what the machine learned is that people that watch violent movies also watch March of the Penguins. Now, what we haven't told the machine to do is think a little bit more, because it wasn't just people who watch violent movies. It was also people that watch romantic comedies. It was also people that watch dramas. Basically, everyone watched March of the Penguins. Right? So the machine is learning that people that watch watch violent movies will also watch March of the Penguins, but we're not also instructing it to kind of bubble that up a little bit and see, well, what differentiates actually people who watch March of the Penguins? When is that unique? And we haven't gone to that more conceptual level there. And symbolics helps us with that, because the symbolics allows us to put the rules in, right? And the logic and the rules behind that. But concepts adds a different level. And that's one of the things that we focus on. So there's kind of that of, have we gone too far with the data? I'd say there's more information in the data that we've actually extracted out. We've just used it as one stream rather than, again, kind of bubbling it up at different levels. The systems part is really important that you bring up. And I definitely think we don't do enough of that. And that's an area that I'm, kind of ashamed from the software industry perspective. We really learned that a lot in software. Often, I would say that we got messed up when we didn't think about the context or the systems that things were going to be placed into, and made it harder to ourselves. So there were very few, at least large enterprise systems, that stood alone. Most of them had to integrate with other. And we know how to do that pretty well. What we've done with AI, mostly in the industry, is we've kind of kept it its own little bubble. And it's this optimization bubble that just sort of spits out answers. And we haven't thought as much, and we need to, on the data side, what's coming in to feed that, and data and understanding. We're getting better at it. We're getting better at having some more thoughtfulness around it, not just regulations, but also thoughtfulness. And then how is this going out? How is it going to be understood? One of my big things is explainability. But it's beyond explainability. It's understandability. When I get an answer, how am I going to trust that this is the right movie for me, or this is the right product for me, or this is the right business action for me to take?
It's interesting you say that, and I think the reason, and that's very when we're seeing this everywhere, even like when companies are trying to build their capabilities, and there's the newly minted data science people or ML engineers who, if you can give them a little bit more contextual understanding about the stack, their performance just goes up. On the point of the easy and hard problems that we started this on, right? I think of it, it's an interesting thing, right? Where I think it was Ben Stansel who wrote this blog called "Does Data Make Us All Cowards?" Right? Because we choose the easy path, which is to just look at the data and say, this is what the data says. The harder part is when you actually then contextualize that and then make a decision based on that, right? To your own Netflix example, just because you got March of the Penguins as a recommendation, are you going to watch it? Are you going to actually or not do it, right? That's a decision beyond just the data. And that's how humans operate too. But I love the way you framed it, which is how do you capture data is just an entity, and then there is context around how that entity came into being, and capturing that will make for better decision. So what is this neuroscience based AI? I mean, I know what you're doing, your team is working on right now at Nara Logics, also very much focused on that, right? Explain the origins a little bit more for me. How does that really balance the two approaches?
So when neural nets were first started, we didn't actually really know how neurons worked. So it was just, we were overloading that term because we like to do that in science. We like to take a concept and go, oh, I understand that enough. Now I'm going to name it that. So we know a lot more about brains now, not near enough, but we do know a lot more. And our co-founder and CTO, who is an exceptionally brilliant person, studied microbiology in undergrad and then artificial intelligence for his master's, and then went into, got his PhD and worked in his postdoc in neuroscience at MIT. He was at Cornell before that. And his real passion was understanding more about how the brain works so he could apply that to machines, because there's so much beauty in biology and elegance and efficiency. I always like to say that, our brains are much smarter than this. And this uses like 25 more times. I work on a sandwich and some crackers, and and this takes much more than that, even though it is brilliant and handy. But how much our brains can do on so few calories is just actually remarkable. And so that's one of his inspirations, is what can we learn from the brain, not to make a direct copy, but actually to be inspired by it. So what that first application of what we're doing is he studied how and when actual physical neural nets form. So when does a neuron decide to reach out and connect with another neuron? You've heard of fire together, wire together, I imagine. So that would be one way that they decide to connect. And he watched that and grew them in the lab to see when they decided to weaken those connections and all. But the work that he did in his postdoc, so that was very cool, really interesting work, and inspires us. So for us, it's how does data decide to connect, right? When do I put a connection between these two things? When do I even form a new concept, as I was talking about, because these things are very similar. So we do that in our platform, is we bubble things up to a new concept. But what's really interesting in his postdoc work, and it's really foundation for what we do, is how do you decide to moderate all of those connections? And while a single neuron does that on its own, because it only has so much energy and it has to decide where it puts those energy for connections, what really happens in the brain, about 25 to 30% of the neurons in your brain are inhibitory neurons. And those inhibitory neurons are really the traffic control. So that's what makes you not be as frenetic as we all feel all the time, actually, in your brain. It really is what helps you decide in that context which pieces of your brain to fire. So what should have happened, let's go back to the March of the Penguin example, is what should have happened is there should have been some inhibitory neurons there saying, okay, while March of the Penguins is trying to be very popular and connecting with every single type of person out there, I'm going to have some inhibitory neurons that are going, you're firing too much and that's causing noise in my system. And that noise in the system is because I'm showing this to too many people. And that's where an inhibitory neuron will come in and do that kind of traffic control. So we have that concept in our platform where you may have data that's pushing you that way, but what we're trying to do is build a balanced network. And so those are the kinds of things that are inspiring to us. So that's why when we really talk about being neuroscience based, it's not because that's where the idea of neural networks came from. It's really that we're looking at the biology and understanding why does our brain decide to have something like inhibitory neuron, and then say, how would that apply when we're trying to understand data exhaust?
That's amazing. That is just amazing. It's like truly inspired by the biology and how neurons work, applying that to enterprise problem solving, right? So organizations have now moved away from asking about, hey, how do I leverage AI? What do I have to do AI, to really look at how do I apply artificial intelligence, machine learning, deep learning, all the techniques to make better decisions, to solve problems, to automate things, and so forth. From your vantage point, what's your view on the state of the market today? What's working? What's not working? Where are organizations in this journey today?
So, first thing I'll say is I'll take it back to what you said before. I still don't think people are thinking from the systems point of view, and that is the state of the market. AI is still, again, in my opinion, from what I see, mostly compartmentalized. So people are running a model, kind of looking at that answer, then you know, going back and kind of deciding and trying to understand it, and it's still in its bubble. Other than things like, recommending low risk pieces, like recommending a movie to me. Other than that, a lot of things are still too compartmentalized in their pieces. That said, the capabilities and the ability to access those capabilities is really out there. So the future is here. It's just not evenly distributed. What's being done and what's available on most of the cloud platforms, for example, is some pretty advanced technology. We just need to learn how to apply it. We have some power tools there that people don't really know yet how to apply, and they don't realize that it's not just I pick up this power tool and it's going to be useful in my organization. And they really need to change. I did a talk at O'Reilly's AI conference. Now at this point, it was probably 5 years ago, entitled "It's the Org Stupid." And where I came up with that idea was there was a Harvard, an HBR article, a Harvard Business Review article that was, I'm pretty sure it was Unilever. And they said, they talked about their AI engine. And I was so excited. I read the headline. I'm like, AI engine, I can't wait. I went in, I'm a technologist, so I love this stuff. I'm like, I'm gonna learn all about the engine. And their engine was all about their organization. And they talked about how they organized around the data. They talked about how they organized around the systems. And so that's when I said, oh yeah, this is what we're all forgetting. We're all forgetting that where AI is going to be successful and successfully used, it's really how our organization thinks about it and rallies around both the data and the systems together. And that's where the technology is way ahead of our ability to use it.
In fact, I was, I think I tweeted it out a few days ago. I got a lot of chuckles on it. It's the people, stupid, right? It's like, the process, the technology, everything else comes secondary. But innately, what makes us unique is we are humans. and we think a certain way, we act a certain way. There is a moderate amount of rationality in most things that we do, but then it's about the people, the org, the people oriented systems before it is about technology. So no, well said. I think that's the state of the market, as you very eloquently put. I love the way you said it, right? Which is the low risk problems are being solved more often than others, right? Which is like, it's an easy thing to do. I can compartmentalize it, solve it right now. But the real opportunity and also the available white space is solving the hard, more complex problems that are more impactful, that touches multiple things. But I want to flip that question into the other side, right? Saying, what does that mean for trust, right? Because when you have a small compartmentalized system that is making semi-automated or fully automated decisions, it's easier to put a bounding box around it, right? When you have this neural network inspired system that is making decisions everywhere, how do you trust that? How do you understand how the decision came about? Explore that for me.
So I learned about that a long, long time ago when I was at Los Alamos, and I was working on optimizing. So my project was to figure out the maximum conductivity of certain polymers. So I worked in a mechanical electrical engineering group, and we were basically trying to make plastics that conduct as well as metal. And so I would come up with some ideas from my modeling, and I would, talk to the chemist there, and I'd say, if you fabricated it in this way, that they'll conduct better. And they would look at me and say, but why? And I said, well, because the modeling shows that. What do you mean, but why? And they said, no, but you got to tell me like why this particular configuration is going to do that, because the way I fabricated it isn't that exact. I can't be as exact as your computer can. So tell me the pieces that are most sensitive. They were basically asking me to do a sensitivity analysis so I would understand. And we could, again, I had a lot of compute power then, so I could go in and do a sensitivity analysis, which has become more popular now in the past few years with AI. But, that was really important learning for me as I've gone through my career is there are very often the but whys. And it's really great that your computer can compute that, but why? And because most people will either, to your point, trust it and just say, well, Netflix knows so much about me, it must know more than I do. And even though this seems like a really strange movie for me to watch, I'm going to trust it and go for it, right? Low risk. Or people are like, look, I have a lot of experience with this, and I'm the subject matter expert, and I'm the one that knows all the different contextual permutations that have happened because I've been doing this for 30 years. Of course, I'm not going to trust that machine. Even, by the way, when it's been proven that the machine is right more often than they are, they will look at that answer, and this has been proven in many studies. People that are experts will look at that answer and say, yes, but this will be the exception. Even if they're right 88% of the time and they know the machine's right 98% of the time, they will look at it and say, this is one of the 2% of the times that the computer's wrong and I'm right. And they'll be convinced of that. And so that's where the machine explaining or saying, these are the things that were most important to me. These are the things that I saw in the data that you might not see. And I actually believe it's that human machine collaboration that's going to succeed. It's going to be able for the machines being able to explain why and show what was important to them. And the humans being able to ask, well, what if that wasn't the case? I don't trust that sensor. I know we had somebody out working on it the other day, and I think the sensor's off, right? So it's that kind of conceptual information, contextual, not conceptual, contextual information that people often have that they want to find out from the machine. Did you know about this? What do you think about that? And allowing humans and machine, humans and machine together win Centaur test or advanced chess. If you want to look at that, humans and machine together win. And so how do we find that right matchup? Not just so humans and machine can work together, but so humans and machines can communicate together. That's what's really important about the explainability and understandability.
That's awesome, yeah. And I think you touched upon a few things that I'd been thinking about. Like trust is a very personal thing. It's a personal relationship you have with any piece of information, for that matter, right, or a system. And I do believe to improve, and I do believe in this vision of augmented intelligence, which is all about just how do I really bring out what's best in humans by augmenting them to give an extension, an exoskeleton that they can actually see the world with data and get that data in their systems, but they can make the better decisions using that as another mode of input, not as a sole mode of input, right? But I've always wondered whether it's actually is it really a data capture problem? Because the context that you're talking about, we don't really have very mature systems or tooling today to capture that context. Like you said, when the Netflix makes a recommendation, somebody's going to tap on the Netflix algorithm and say, "Hey, but take a look at these things. These are other things that I would think of as a human being." We don't have a lot of those kind of systems in play. And I think partially when we started the conversation, we started talking about the move from the expert systems and symbolic logic to purely data driven kind of world. And I believe that's the missing piece. And the way you solve it is, start by building a data capture system that can then go and capture human context into the machines beyond just the data. And then, you evolve that into how do you create a communication system that allows for a trusted, framework or a network between the humans and machines, right? So,
I think that's interesting. I'll disagree with you a bit on that data capture side. We have so much more data than the data we're using right now, and so I think that. And gosh, I really don't mean to pick on Netflix, but since we have this common thread here, because I think Netflix is actually doing a lot of things right. I'll give them that
sure.
in a minute. But I think that it's our systems that we haven't evolved to actually take into account the data that we do have. So we Netflix knows the time of day that I watch a movie and doesn't necessarily take that into account. Netflix knows, again, the example of what was this March of the Penguins considered in its concept, it has the meta information about the movie too, and that could feed into, should I actually recommend this as a violent movie? It knows the ratings on it and things like that it could take that meta information and use that data to actually help contextualize. And I don't think we're doing enough. Well, I know we're not. We're not doing enough of that with the data that we have that could actually improve. Now, on the Netflix side, again, I want to compliment them because they do make a lot of great recommendations, and it's easy. We don't even notice the ones that they do well on. It's the ones they don't do well on that make us laugh and and make fun of it. But they do really well on it. And one of the things they did very early on that not enough people are doing is they have tens of thousands of models. They don't just have one model for this. They really have created a model network, really, even. And people aren't thinking enough about that right now. They're thinking more, I create one model and then they're just letting it sit there. And they're not kind of retraining or conceptualizing or splitting it off so that they have another one. And you'd be surprised at how many companies created an ML model 2 years ago and still haven't retrained it, and it's just letting it go. And that's where we need to be doing better. We need to actually we call it machine learning, but we let the machine learn, and then we go, okay, don't learn anymore, just go in the corner and act like nothing's changed. And so there's a lot of information that the data, and I'm saying information because that's a little high level, to your point, that we need, but I would argue we have a lot of it. We're just not using it.
Yeah, fair. And I think what I meant by capture was also, are you really capturing that context? Not so much, are you collecting the data? Of course you are, right? I think, are you really paying attention to the parts that you should be, right? No, this
Yes.
is fascinating, Jana. What's some quick words of advice for organizations who are in their AI or data journey today, right? Give me your top three advice for them.
So I would, my number one thing is AI is not just AI, it's software development. And so we have a lot of great practices. I'm not saying we're terrific at it, but as an industry, we have a lot of great practices that we know about and how to deliver software. Follow that. The second thing is know and understand your data. I talk about not just having a data wizard or a data scientist, but really having a data whisperer. If you think of the dog whisperer, he didn't just go in and say train the dog. He also trained the people, and he understood what would work for those people too. So that's the context piece.
Yeah.
And so I'm really, data feeds AI. If AI is eating the world, data's feeding AI. And so having someone or some group that's really understanding the data so they know the context that it was created as well as the context that it applies, I think is critical. And then the last one is what we were talking about before. It's about the people. And so I covered that it's a technology. I've covered that the data is critical, and the people who are building it, this isn't up to one data science team, right? You need data scientists. You need people that understand how to work with data, but you also need the business people. You also need the technologists. They all need to come together to actually make AI useful. And that AI needs to be continually learning,
That is
not
awesome.
just learned once.
Awesome. Jana, that was amazing. That was an amazing piece of advice. I love that. Technology, and make sure that you embrace it and learn around it. Data and contextualize it. I love the way, the data whisperer, that's going to go, I'm going to talk a lot more about it. That's you got me on that one. And then people, don't forget the people for sure. Jana, this has been fascinating. I had two rapid fire quick questions for you.
Okay.
One is AGI, artificial general intelligence. Do you believe in it? Do you worry about it? Do you even care?
I don't worry about it because I think it's, I don't even think my grandchildren's grandchildren will be around for it. So I have zero worries about it. The only thing I worry about in the context is that we're spending too many smart people are spending too much time worrying about that when we could be solving other problems that really make a huge difference in our world.
Got it. Got it. Well, my second question is a personal question. What's your personal power practice outside of, working in AI?
I'm a runner, but I'm not a power runner, so I'm not sure that counts. I
It
just
does.
run far.
That's awesome. You're a runner. And I think, like one of the things I started asking this question just to understand the side of people beyond just the AI and data. And it kind of tells a lot of interesting stories. I mean, I've had some folks told me, whatever it is, I wake up every morning, have to go for a walk. And it is like that 20-25 minutes, it's completely decompresses me and gets me ready for the day and so more. Right. So, it's fascinating. Jana, this was fantastic. How can the viewers and listeners get in touch with you? Where can they find you on the internet?
If you know my name, I'm really easy to find. So, and
I found
I'm
you.
not on Instagram because I'm not cool enough for that, but I am on Twitter, and I'm on LinkedIn, yeah, I'm pretty easy to find and happy to
Awesome.
talk. I love interaction. You and I talked about how much fun it is to talk with each other, and other folks, because you're constantly learning. And I've certainly learned a ton from you, and I know that other people do as well. And I'm always happy to hear people's perspective on what's happening in the industry or what's happening in their organization, particularly around AI.
That's awesome. Jana, I'm sure, I mean, I enjoyed a lot. I learned a lot in this conversation too. And I'm sure the audience is going to learn a lot too in this conversation. So thank you so much for taking the time. This was fantastic.
Thank you. I really appreciate it.